Hi y'all. So we're gonna go ahead and go over lesson 4, which is a one sample mean t-test. Um, so this is just taking everything that we've learned already about a t-test and formulating a step-by-step process so that you can get full points on your free response questions. So the main idea. Now that we have spent some time learning about the basics of a hypothesis test and the t-distribution, it's time to put all these ideas together and run a formal hypothesis test. These are the types of tests that scientists, engineers, and psychologists use to find out if they have significant evidence or not towards their claim in their research and everyday jobs. Over the next few months, we will play the various roles of researchers to identify whether we have significant evidence towards proof of an alternative hypothesis. So, this template right here is for a one sample mean t-test. And every time you do one of these tests, whether it's a z-score distribution, a one sample mean t-test, or later on when we learn about like a two sample mean t-test, you need to write the test at the top. So we need to name the test. Okay. And there's two ways that you can name the test. You can name the test like I did up here, saying one sample mean t-test, or using the equation. This also names the test. Okay, so I've done it here twice to ensure that you will for sure get the points that you deserve. So then the template is divided into 4 parts. Part 1 is our conditions, then our parameters, our math, and then the conclusion. Our conditions include random sampling with 10% condition met, or it's a random assignment. So if the problem says SRS, then you're fine. If it wasn't an SRS, but the population was small enough, so if the sample was small enough in comparison to the population, then it's fine. Okay. It also needs to be a normal sampling distribution. So either the population is normal, or we apply what we learned from CLT. So if n is greater than 30, CLT applies. So that means it's a normal sample model. If n is less than 30, we need to create a box plot in our calculators and sketch that box plot onto the paper. And there is a way for you to see whether the box plot has outliers or not. If you go into your calculator, it's going to be the button that has a box plot and then dots on the side. Then you go into your parameters. So we've been practicing this where we have mu is the true mean of whatever the context of the problem is. You form your hypothesis. So mu is always equal to mu naught. So this is the given population mean. And then you must choose what your alternative hypothesis need to be. In the math section, we have our t-statistics calculation with the equation shown. You have to write the equation before you plug in any numbers. You need to state the degrees of freedom. So you could say df equals blank. Okay. You have to draw your normal model with your mu naught value in the middle. Okay. You got to shade whatever region that you need to, and then tell me the p-value. Okay. In your conclusion, there's 2 conclusions that you can make, depending on what the p-value is. I like to think of the 3 knots conclusion for when p is not less than a. So because the p-value of our sample mean, or because the p-value is equal, and I'll update this so it looks better for y'all, equal to blank, which is not less than alpha, meaning the p-value is greater than alpha, we do not reject the null hypothesis. So that means that we fail to reject. We do not have significant evidence that the alternative hypothesis is true. Okay? And we're going to go through some examples to help you understand this better. The other conclusion, so that's when p is less than alpha. So because p value of blank is less than alpha equals 0.05, we reject the null hypothesis. We do have convincing or significant, so you can choose either way to write this, evidence that the alternative hypothesis is true. Okay, so let's go ahead and do some examples to help you understand what's going on here. So model problem number 1, this is when you're given data. Okay, so when you're given data, you can put this in a list, and when you do your one mean t-test, you can select data and insert the list, or you can do the one var stat like we did in class to excuse me, to figure out what the sample mean is and what the sample standard deviation is. So during an angiogram, heart problems can be examined via a small tube, a catheter, threaded into the heart from a vein in the patient's leg. It's important that the company manufactures a catheter maintain a diameter of 2 millimeters. Each day, quality control personnel make several measurements to test the tubes. If they discover a problem, they will stop manufacturing process until it is corrected. The following measurements of the diameters of 12 catheters are given below in millimeters. Is there significant evidence that the manufacturer of the catheter are not meeting the medical standards? Provide statistical justifications for your answer. So I know here that n equals 12. And after putting this into my calculator, I know that x bar is equal to 1.99 and sigma x bar, so standard deviation of the sample, is equal to 0.03. Then I'm going to divide my paper into 4. So I'm going to draw 4 boxes. Okay. We have our conditions, our parameters, our math, and then our conclusion. And I'm going to zoom in on each of these boxes so that y'all can easily see. So let's go ahead and start with the conditions. Okay. The condition is first, it needs to be a simple random sample. And in this case, we're going to assume because it didn't tell us. We know that n is equal to 12, which is less than 30. So we need to create a box plot to see if this is symmetric and has no outliers. So if I created a box plot in my calculator, I have 2.0 here, 1.95 here, 1.9 is here, 2.5 is here. So we can tell that this is symmetric enough and there are no outliers. Okay, so we're good there. Next, we're going to move on to parameters. So parameters, you need to first state what your parameter of interest is. And this always needs to be in context of the problem. So we're going to let mu naught be the true mean diameter of all catheters. Okay, and we're saying all here because this is the population. HO, our null hypothesis, is mu is equal to 2 millimeters. And HA, the claim that we're trying to make, the alternative hypothesis, is that mu is not equal to 2.00 millimeters. Okay. Moving on to our math, I'm going to start with my T statistic equation. And I'm going to plug in my numbers. So I get 1.99 minus 2.00 divided by 0.03 over the square root of 12. And once I put this into the calculator, so you're going to put this into your calculator, either actually calculating this value or putting it into the one for the t-test, you get negative 1.1 you get negative 1.18. Next, I need to state my degrees of freedom. So that's df is equal to n minus 1, which is 12 minus 1, which is 11. Okay, I'm going to draw out my normal curve. In the middle is 2.00, and this is the shaded area. Okay, so P, once I put this into my calculator, the shaded area is the two-tail test. So this is a two-tail test, since the alternative hypothesis did not equal to the mean. So P is equal to 0.26. So in conclusion, okay, if the true mean diameter of all catheters is 2.00, the probability of our sample not being 2 is approximately 26%. Since 26% is greater than alpha equals 5%, we fail to reject HO. So we do not have significant evidence to stop the manufacturing process. Okay. So to read this out one more time all together, if the true mean diameter of all catheters is 2 millimeters, the probability of our sample not being 2 millimeters is approximately 26%. Since 26% is greater than alpha equals 5%, we fail to reject HO, and we do not have significant evidence to stop the manufacturing process. We're going to go ahead and do one more model problem. This time, the model problem gives you a statistics. So, a city representative claims that the policemen in the city earn an average of $52,000 per year. The local paper believes that the mean salary is less for the beat cops. A survey conducted by the paper selected a random sample of 20 beat cops and found a mean salary of $51,300 with a standard deviation of 1,900. Assumed normality for the population of salaries of beat cops is reasonable. Does the local paper have evidence to support their claim? Justify your answer using statistical evidence. So we know that mu is equal to 52,000. I know that x bar is equal to 51,300, and I know that sigma x bar is equal to 1,900. So again, I'm going to create my 4 boxes on paper and name my conditions, my parameters, my math, and my conclusion. Okay? Starting with my conditions. The problem says that this was a simple random sample, so we're good. We also know that CLT applies since population is assumed to be normal, right? It says that in the problem. It says to assume the normality. Next, we're going to go to parameter. We know that we're going to say let mu naught be the true mean salary of beat cops. Okay, we're getting specific to beat cops because we're looking at beat cops and not at all the policemen. So then HO is mu equals 52,000. And HA, what we're trying to claim is that mu is less than 52,000. Moving on to the math. T is equal to 51,300 minus 52,000. All of that divided by 1,900 over the square root of 20. This is equal to negative 1.65. Okay, so remember that before this, I actually have to write out the equation. Okay, don't forget to do that first. Okay, I also missed something. I need to write one sample mean t-test. And if I go back to the last page, I actually needed to write that here too. One sample mean t-test. Okay, so I lost partial points there for not doing that. So don't forget to do that. Okay, moving back. So now I know what my t statistics is. I know that my degrees of freedom is equal to 19 because 20 minus 1 equals 19. I'm going to draw out my curve. So in the middle is going to be 52,000. I'm shading this way because my alternative hypothesis says that it's less. And I get a p-value of 0.0567, which is approximately 0.06. So let's move to the conclusion. If the true mean salary of beat cops is $52,000, then the probability of our sample mean and less, we have to add and less because that's what our alternative hypothesis says, is approximately 0.06. Okay, since the p-value is greater than alpha equals 5%. This becomes our three knots. We cannot reject HO, meaning we fail to reject HO. We do not have significant evidence to conclude that beat cops make less than $52,000 a year. Okay. You are going to go ahead and complete the practice problems. Once you have done so, the answer key has been posted onto Google Classroom for you to be able to check your answers.